All right. Hi, it's you. You're back. You're here again. You're back on Chem with Chem. No, welcome. In this session, this one is this one, I don't want to call it a blast from the past, but I've gone to the archive for this one. This is an adaptation of an online lesson. Now, in this session, we're actually looking at naming organic compounds, specifically alkanes and alkenes. Now we're going to be doing the same thing for alcohols, for carboxylic acids, and we'll look at the reactions. We'll have a whole series covering organic chemistry. Some of the videos are already posted while we're working on posting the others. So please turn on post notifications so you do not miss any time new content is added. Be sure to like if you find value and share with a friend. If we're drawing, draw with me. Practice drawing because you'll be drawing on the questions for organic chemistry. There's a guarantee that you're going to have to draw something. It's not just theory. So draw with me.
All right, so we're looking at 2-methyl propane. Let me just check back to ensure that that's, yep, 2-methyl propane. All right, so first things first, we need to identify the family that it belongs to. So we look at the end part, just like we look at our last name. It's a propane, it's an alkane. Prop is telling us that it's 3 carbon atoms, and ane is telling us the family that it belongs to. So we know it's going to be an alkane that has 3 carbons. The methyl right here is what we call a group or a substituent. And then the 2 that is right there is telling us the position or the location of this substituent. There's no functional group per se. So the functional group is just a bunch of carbons singly bonded to hydrogen or carbon singly bonded to carbon. So there isn't a functional group. If we're talking about an alkene, then we would have our carbon-carbon double bond. Or if we're talking about an alcohol, we would have the OH group, etc. So 2-methyl propane. So we'd need 3 carbons in the chain. And of course, we have to dress up. We have to put on our hydrogens. Well, they said that it's 2-methyl propane. So on carbon 2, and it doesn't matter which side you count from. 1, 2, 3, or we could count 1, 2, 3. Either side you count from, the one in the middle is 2. So on the one in the middle, we have a methyl group. So we'd put CH3. All right, and then we dress up the others with hydrogen. And all this is saying is that on carbon number 2 of this structure, which has 3 carbons, on carbon 2 is a methyl group. Cool? So we call it 2-methyl propane. Note that this methyl could have been drawn in a more structural way. We could have drawn it like this instead of condensing it to CH3. That is the same thing, saying that on carbon 2, there's a methyl group. All right? Any questions?
Yes, sir.
All right, go ahead.
For the part where it said methyl, right? And
Go
we
ahead.
put CH3. Did you use the CH3 because that would be the formula for propane, or because that's what you would ordinarily use for methyl?
All right. Methyl, remember, methyl is coming from the word meth. The prefix meth means 1C. So if it were CH4, that is methane. So the methyl is just 1 hydrogen less. So pretty much methyl is the CH3 group. Whenever you have a group side group or a side chain or a group with just one carbon, we call it methyl. So CH3 on a whole is just the methyl group. So we can do it as CH3 condensed as written above, or we can do it like we have it here. So that is the group. And another thing to note, the way when we draw it like this now, this, the longest chain, whichever way you want to count it, would still contain 3 carbons. So it means, therefore, if we're counting, we could now count 1, 2, 3. So even though we bend it, it's still the longest one. So identifying the longest chain doesn't necessarily mean it is straight. All right, the second one is 2, 3 dimethyl pentane. 2, 3 dimethyl pentane. So for this one, it's telling us that the longest chain is going to have 5 carbons. Right, longest chain will have 5 carbons. So all the things that we see at the beginning right here, all of those things that we see, the numbers that we see there is just telling us that it's pretty much giving us the location of whatever groups we're going to have. So di here is telling us that we're going to have 2 groups, and the groups that we have are the substituents, they are the methyl group. So we're going to have a CH3, or better yet, 2 CH3s attached to this long chain with 5 carbons. The number 2 is telling us one is going to be at 2, and the number 3 is telling us that one is going to be at 3. It's like telling the address, the street address. So that 30 is the number of the street. That's where we would need to drive up if we want to find your house. So what this is telling us? This is telling us that at carbon number 2, and just to make things simple, I'm going to count from left to right. So 1, 2, 3, 4, 5. So on carbon 2, there's a methyl group. So we're going to write it as CH3. And then on carbon 3, there's another one. So I'm going to put it down here because up top is, I could put it here, but I don't want crowding. So we have a methyl group on carbon 2, a methyl group on carbon 3. But this is not finished. We have to dress up the rest of the molecule by putting on all the hydrogens that's supposed to be there. And if you notice, there isn't a carbon-carbon double bond, so it means this compound is saturated. So we say saturated because we don't have any carbon-carbon double bond. Okay, so here we go, 2, 3 dimethyl pentane. We have a methyl on carbon 2, and we have a methyl on carbon 3. All right, guys, questions?
I was going to ask if no double bond means it's always saturated.
Yes. Once there's no double bond, it's saturated. It's telling us the carbon is just bonded to hydrogen and to carbon. Single bond. So in a sense, saturated means all single bonds, no double bonds. Very good question. So let's put that there as well. So saturated also means all single bonds. All right. So the next one is saying 3-ethyl 2,4-dimethyl hexane. All right. So new page for this one. 3-ethyl 2,4-dimethyl hexane. Dimethyl hexane. So note, one thing to note, numbers are separated from letters using a dash, and numbers are separated from numbers using a comma. Now, according to syllabus, we don't really need to go beyond carbon number 6. All right, so here we are. We have longest chain being hexane. Hex means 6. So we'll need a
For alkanes, the general formula is CnH2n
plus 2.
plus 2. Okay, was correct.
CnH2n plus 2.
And then for alkene, it's CnH2n.
That's right.
Okay, thank you.
You're welcome. So we'll have a carbon skeleton with 6 carbons because we are saying hexane. All of the psalms and songs and so on that come before it is just telling us what is on it. But the principal thing is that it's an alkane and it's made up of 6 carbons. Now, traditionally, because in the Western world we read from left to right, we're going to count 1, 2, 3, 4, 5, 6. So there's if this is carbon 1, this is carbon 2, this is carbon 3. There's an ethyl group on carbon 3. So we know that the methyl group is CH3. That's methyl. For the ethyl group, we just need, so this is the methyl group. The ethyl group would just add a CH2 to this. So the ethyl group would be C2H5. Or we can draw it as this. It looks like this. All of these would have on the H, and it would be short 1H, 1H short of ethane. So it has 2C, so we call it ethyl. So this now would take this group, whether we want to do it as here or as here, we'll take that and we'll put that on carbon 3. So I'll do it small so we don't hinder the other carbons. So there we are. So we have an ethyl group on carbon 3. So 3 ethyl, and then they said 2,4 dimethyl. So on carbon 2, there has to be a methyl group, which we'll draw CH3. And they said that on carbon 4, there's a methyl group. So we'll draw it right here. Carbon 4. And you must be wondering, why the name? Why do you say the 3 before the 2? It's not a matter of saying the 3 before the 2. But if you look in the alphabet, you'll notice that E comes before M. So in a sense then, whenever you have different groups present, you have to state them alphabetically. If it were just methyl, we'll just state the position like we did in the question before. But in this one, we have an ethyl group and we have methyl groups. So we'd have to know name based on which letter comes first in the alphabet. We name alphabetically. So ethyl comes before methyl, so we'd name the ethyl first. So carbon 1, 2, 3, 4, 5, 6. Yeah, the ethyl is on carbon 3, but we name it first because E comes before M. And to help you remember this, you can think of CFCs, chlorofluorocarbons. They don't call them FCCs, right? They call them CFCs. CFCs because chlorine comes before fluorine. So carbon is the main thing, but chlorine comes before fluorine in the alphabet, A, B, C. So that would not be that. So we need to dress up, of course, always put on the hydrogens, ensure every carbon is taking part in 4 bonds. There we go, there we go, there we go. And the numbers that I have right here, you don't have to keep the numbers, I just put them on, so we use them as a guide. So we know which carbon we're calling 1, which one we're calling 2, etc. Name the following compounds, all of which have the molecular formula C6H14. All right, so we're on to part B. We're just going to name them. So I don't need to write for this one. We just, for the first one, it's straight. We're counting the number of carbons. 1, 2, 3, 4, 5, 6. So there are no double bonds. We only have carbons bonded to carbon, bonded to hydrogen. So we know it's an alkane. So the longest chain has 1, 2, 3, 4, 5, 6. So what would we call that?
Hex something.
Hex something. It's an alkane. So what's the last name? What's your last name?
So it would be hexane.
Hexane. Good. Once it's an alkane, we have to, the last part has to be ane. So as you said, yes, that will be hexane. All right. So back to drawing. So that would be hexane. And what we see right here, CH3, CH2, 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 4 of them, CH2, 1, 2, 3, 4, 5, CH. Okay, then writing is going, CH3. So we have all of 6. The way it's represented here is the condensed formula. What we did earlier on, the drawing we did earlier on, those were the structural formula or the displayed formula. So this is hexane. It has 6 carbons, so it's hexane. The next one, let's draw this. CH3, CH, on this carbon we have a CH3, then we have CH2, CH2, then CH3. We name based on the longest chain. So if we count, we notice the longest chain, we could look like this, and we get 1, 2, 3, 4, 5. We could have looked the other direction as well, and it would have still been 5. 1, 2, 3, 4, 5. Either way, it's 5. There's another way to look at it. All right, we could have looked at it like this, and the longest chain would have still been 5. So if we count from this end, 1, 2, 3, 4, 5. That's one way. Let's use another color to highlight this. If we had counted this way, then this would be 1, 2, 1, 2, 3, 4, 5. If we had counted this direction, then we would have 1, 2, 3, 4, 5. Now, one of the things with naming, whenever there are groups or functional groups, we always want to name such that the position of the functional group or the group gets the smallest number possible. So if we count from right to left, this carbon right here that has the methyl attached would be on carbon 4, which we don't want, because if you count from left to right, then this carbon would be carbon 2. So let's get rid of some of the clutter that we have right here. So again, this is carbon 1, this is carbon 2. On carbon 2, there's a methyl group, so we'd have to say 2 methyl, and the longest chain is 5 carbons, so it's 2 methyl pentane. Again, we use our prefixes. Pent means 5. CH3, CH. Attached to this, we have a CH3. Then we have CH. Attached to this is a CH3. Then we have another CH3. Longest chain, any way you want to look at it. Let's look at all the different ways. So naturally, going across 4 carbons. If you see that, say I. Another way to look at this, we could have counted this way, zigzag approach. And the longest chain would have still been how much? 1, 2, 3, 4. It would have still been 4. And we could have counted this way. So that's one way, this one way. You can always go left or right, forward or backward. And we could have counted the long way, which we just mentioned. But we like the straight way. So let's number. All right. So this is 1, 2, 3, 4. Or 1, 2, 3, 4. On carbon 2, we have a methyl group. And on carbon 3, we also have a methyl group. So the groups present are methyl. We have to state their location, even when they're the same group. So one is on carbon 2, so we'd have to put 2. One is on carbon 3, so we'd have to put 3. And we use a comma to separate the numbers. So it's 2, 3, and because it's 2 of them, we say di. Methyl, and the longest chain is 4 carbons, so it's butane. 2,3 dimethyl butane. If I had counted from the other side, it would still get the same thing, because from the other side, going this way, this is carbon 1, carbon 2, carbon 3, carbon 4. So either way, anyway would have counted just now, would have gotten the same thing. And then part D is a little easier. This one is one of the easier ones. CH3, CH2. We have a CH right here. Attached to that, we have a CH3. Then we have a CH2. Then a CH3. All right, longest chain. Looking on, longest chain as, let me see, 1, 2, 3, 4, 5. Well, it's 5, and in the middle we have a CH3 on the middle one. Well, you have 5 fingers. Anyway you count from, whether from daddy finger or little finger, the middle finger will still be number 3. So it's a similar case right here. Anyway you count from, the methyl is on carbon 3. So we'll name this 3 to state the position. Put your dash to separate your letter from your number. So it's 3 methyl pentane. And then the last one, we want the cycloalkanes. The syllabus doesn't stipulate that we look at cycloalkanes. So you can ignore number 2 on the worksheet. So let's just look at the last one, E. CH3, C. And attached to that C, we have a methyl up top and a methyl below. Then we have CH2. Then we have CH3. Looking at this, longest chain is, well, let's count from this way. Longest chain is 4. Anyway we count, this is carbon 2. Carbon 1, carbon 2, carbon 3, carbon 4. But most persons wouldn't have counted that way. But the longest chain is 4. 1, 2, 3, 4. Now this is interesting. We have a methyl on carbon 2 and a methyl on carbon 2 again. It doesn't matter if it's the same carbon, you still have to give it. You still have to tell the location of each group. So you would say 2, and you'd put another 2 dash, then you say dimethyl. Longest chain is 4, so that would be butane. So yes, we still put the 2 twice to say, hey, one is on carbon 2 and the other one is on carbon 2. So we'll say 2, 2 dimethyl. Di to say it's 2 methyl groups.
Sorry.
Yes.
What if it's a case where you're counting backwards and instead of the 2, you get 3 right here? So.
All right. Good question. Now, if we had counted backwards, let's draw this again. CH3, C, CH3, CH3, CH2, CH3. Again, if we had counted this direction, then would have said 1, 2, 3, 4. And that would have given us 3, 3 dimethyl butane. But this though is wrong, because you want to get the numbers being as small as possible. So when you're given the location of your groups, you want the numbers to be as small as possible. So in a sense, 3, 3 versus 2, 2. 2 plus 2 is 4. 3 plus 3 is 6, which is smaller.
4.
Right. So you'd use the 2, 2. So you always number such that the location of your group or your substituent gets the smallest number. All right. And if you look back at, if we were to look back at B, when we named 2-methyl pentane, let's pull that up. Okay. I don't think I have that one. Oh, I lost that one.
Sir, I have a question.
Go ahead.
Why wouldn't it be how you got butane?
We got butane. All right.
Yes,
The longest chain is 4.
yes.
So
I have that part.
longest chain is 4, and it's an alkane, so it would have to be butane. So that's the first thing we establish. Longest chain that determines the parent name. How many carbons make up the longest chain? 4. It's an alkane, so it will have to be butane along with all the things that are on it. So longest chain 4, hence butane.
Okay, sir.
All right.
Now, we've come to the end of this session. Be sure to look out for the next video in this series, part 2 of naming organic compounds. Remember, like, share, subscribe. Couple later.